My name is yakun. This is my final project report of MIS 4550. My project is about house price prediction. House price is dynamic, while purchasers and sellers may have really different view about the same house. Some individual sellers and purchasers decide the house price by intuition or feelings. In this way, they can't have an accurate judgment about the house price. Buying the house bargain, winner is the one who has more accurate judgment of the house price. This project provides a reliable way to determine the house of a price. I collect the data from Kaggle. The dataset consists of 21,613 observations with 20 columns: the date of bargain, the price of house, the number of bedrooms, the number of bathrooms, area of living room, area of lot, number of floors, is there waterfront, the view of the house, the condition of the house, the grade of the house, the area above ground, the area of basement, in which year the house built, in which year the house renovated, the zip code, the latitude and longitude of the house, the area of living room in 2015, the area of lot in 2015. In my analysis, the first part is data preparation. Here we can see the year renovated has zero value. It means the house has never been renovated. So I replace the zero value by the year built and minus them by 2015. This gives the age of the house, and in this way I can just use one column and makes the value more meaningful. And check the non-values, it shows there's no non-values. Since I just want to research relationship between house status and its price, so I dropped zip code, latitude, and longitude. Here is the prepared data. The independent variables should be columns except date and price, and the dependent variable is the price. Here is 14 independent variables in total, but too many variables is not good for the model, so I can't use all of them. The next part is about feature selection. I try to use RFE, recursive feature elimination method, but the dataset is too large for my laptop to apply RFE, so I use lasso model to select features. Here I combine lasso CV and standard scalar into pipeline to get the coefficient of every independent variables. Here we can see SQFT lot and the SQFT above has coefficient 0, so I drop them. Then I need to find the highly correlated independent variable pairs and drop one of them to eliminate multicollinearity. So here we can see there is 1, 2, 3, 4 pairs. 4 pairs independent variables which has correlation coefficient greater than 0.7. So I need to drop one of them in each pairs. I choose SQFT living 15, SQFT lot 15, and SQFT living. So now we have dropped 5 variables in total. Now we have only 9 independent variables. So here is the modeling part. The first, I try to use multi-layer perception regression. I combine it with standard scalar into pipeline and fit the model by the selected features. Here This model scores 0.66 in the train set and 0.56 in the test set. We can see in the test set it still performs good, and the difference between two scores is not much. So it shows non-overfitting in this model. Then I try to use grid search to find the best parameter for the ridge regression. Here I combine the standard scalar and range regression into pipeline and use grid search to find the best alpha for the ridge regression. Here gives the result. The best alpha is 0.0013 and the best score is 0.59. Then I use the best alpha to fit the test set. We can see it scores 0.59, so it's almost the same in the train set and test set. It shows non-overfitting. Then I use principal component analysis to the dataset. This method can reduce the dimension directly, so I didn't use the selected features but use the 14 features. So here shows the components, and this is plot of explained variance ratio of every component. We can see except the first component, other components ratio is almost equals to 0. By the calculation, we can see the first component explain 99.98% variance. So we can just use the two components to fit the model. Here I used lasso to fit this model. Actually, I have tried several methods, but lasso is the best. The result shows this model scores 0.51 in the train set and 0.50 in the test set. Two scores is really close, so there is non-overfitting in this model, but the score is lower than the previous model. Finally, I tried the linear regression. The linear regression scores 0.59 in the train set and 0.56 in the test set. So since the twinned ridge regression performs the best in the test set, so I think this is the best model to predict the house price. For some situation, people don't need accurate prediction price, but they need a price range to as a reference. So to solve this problem, we need the classification method. Firstly, we need to transfer the price into categories. So I check the distribution of the price. We can see most of price lower than 1 million, but the greatest price is almost 8 million. So if I want to make it a balanced design, my last category may be from 1 million to 8 million. But if you tell a house beginner that a house price is within this range, it helps nothing to him. So I need to drop the outliers. Here I calculate the upper inner fence. Price greater than this value should be potential outliers, and after dropping them, I use 20s, 14s, 16s, and 80s percentiles to set 5 categories. And after this, I used several classifiers to fit the model. It shows the random forest classifier has the highest accuracy, 0.42. Comparing to random guess accuracy 0.2, it's a helpful classification method which can be a reference in determining a house price range. So The regression model gives scores 0.6 and the classification accuracy is 0.42. Both of them is not that good. I think this is because I dropped the location information at first, but sometimes location is decisive to the house price. Two adjacent blocks, their house price may differ from each other a lot. So for my future work, I may transfer the zip code, latitude, and longitude into blocks or district and take them as new variables into research. I think in this way I can improve the model a lot. But for now, my suggestion is to find the prediction price by my model first and visit the house. And after visiting the house, adjust the prediction price to get the final house price.